GCSEs are just around the corner, so I thought I would summarise the whole of GCSE Maths in one video. I did my GCSEs a few years ago and found videos like this super useful, so I hope you do too. To get the most out of this, I recommend taking brief notes on each of the topics as I go through them, and then you can use those to practice past papers in the lead up to the exams. Watching this the day before your exam for a little refresher is also going to help a lot, but I don't want to waste any more of your time, so let's get to it. I hope you enjoy. Here we have the whole of GCSE Maths in one video. I have split this video up into 6 main topics: number, algebra, graphs, ratio, proportion and change, geometry and measure, and probability and statistics. As we go through the video, you will see I have divided these topics up into subtopics as well to go through each individual topic. I thought I would put this in here as well. So this is from AQA, and Edexcel have the same numbers, so don't worry about that across exam boards. When it comes to those exams in May, this is how the exams are going to be split up based on those topics. So as you can see, for topics like algebra, number, and ratio, they tend to come up a little bit more than the last two in both foundation and higher. Now let's get on to the actual content of the video. I have filtered everything from the number topic down into these 12 subtopics. Let's have a detailed look at each one of those. Starting off with BIDMAS. On the left here, what does BIDMAS stand for? B stands for brackets, I stands for indices, D stands for divide or division, M is multiply, A is add, and S is subtract. Now an example on the right hand side, 30 minus 12 divided by 6 times 3 minus 1 all squared. Now firstly, we always check our brackets. We have brackets here. We rewrite this whole line exactly the same, but we change what's in the bracket. So 3 minus 1 would become 2, and then it's 2 squared. Next on our list is the indices. As you can see, we have an index on the 2, which is squared, so we're going to square the 2. But again, just to make it nice and neat, I would rewrite the line each time. So we have 4 there now. Finally, is there any dividing? Yes, there is. So we would do 30 minus 12 divided by 6 is 2. And we just write the times by 4 after that. Multiplying, yes, we have multiplying. 30 minus 2 times 4 makes 8. And 30 minus 8 is going to be 22. And that's our final answer. So using this method to solve any BIDMAS question should mean that you don't get any wrong and you get the order right every time. Next on our list is the prime numbers. Now here is a little definition of the prime numbers at the top. So prime numbers only have 2 factors, 1 and itself. The first 10 prime numbers, pause this just to try it yourself first. We have 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. Now a lot of you may be thinking, why is 1 not a prime number? If you think of the factors of 1, the only numbers that make 1 is 1 times 1. This means that 1 only has 1 factor. For our definition of a prime number, we need to have 2 factors. So that is why 1 is not on this list. Next on our list is negative numbers. Here on the left we have all the rules that you need for negative numbers. However, as you'll see in the examples, these are applied slightly differently depending on whether you're multiplying, dividing, adding or subtracting. So when we are multiplying and dividing, we can notice we have 2 negatives straight away. This means our answer is going to be positive by following rule number 2. Then, once we've decided what sign it's going to be, we just do 3 multiplied by 6 and we get 18. Similarly, for the second one, we have a negative number and a positive number. Now, negative and a positive makes a negative, so it's going to be negative, and then 32 divided by 4 is 8. Next, 6 multiplied by minus 8, we have a positive and a negative, so it's going to be a negative, and then 6 times 8 is 48. I personally find these a little bit easier because you can always decide whether the sign is going to be positive or negative straight away. When it comes to the adding and subtracting ones, the signs only follow these rules if they are next to each other. So if we have a positive here and a negative next to each other, that's going to make a negative. And we can kind of go ahead and do that for all of the questions firstly. So positive and negative at the end makes a negative again. Then we have minus 2 take away 4. If we're starting at minus 2, and we take away 4, that leaves us a minus 6. So you can see, even though both of these numbers are negative, the answer is still negative, and that's just because of the different rules when we're adding and subtracting. 6 plus 10, nice and straightforward, is just 16. And then 3, take away 1, is just 2. My biggest tip with negative numbers is just to take it slow and double check everything that you've done, and always remember these 4 rules here. LCM and HCF. Find the HCF and LCM of 32 and 48. Now HCF and LCM always follows the same method. We first of all want to start off by doing some prime factor trees. 32 can be written as 4 and 8, 4 times 8. We can break these down further into 2 and 2 and 4 and 2, and then the 4 goes down to 2 and 2. I like to circle the prime numbers after, so here we just have a load of 2's. Next we do exactly the same but for 48. We have 6 and 8, 3 and 2, again circling those. 8 is going to become 4 and 2, we circle the 2, and 4, we have 2 and 2. What we would then do, as an optional step, you can write it as the product of prime factors. So this would be 2 to the 5 here, and 48 can be written as 2 to the 4 multiplied by 3. We then make a big Venn diagram and input all of those prime factors into the Venn diagram correctly. So you can see all of the ones that are the same will go in the middle. Here we have 5 2's, but in the 48 we only have 4. So we're going to put 4 of those 2's in the middle, an extra 2 on the 32, and then an extra 3 on the 48. The HCF will then come from multiplying all the middle numbers together. And we know that 2 times 2 times 2 times 2, 2 to the power of 4, is going to be 16. The LCM is going to be every single number in here multiplied together. Now a little shortcut with this one, we already know that all the numbers here multiply together to make 48. So ultimately it's just 48 multiplied by 2, and that would be 96. Next we have standard form. Up in the top left I have written the general form of standard form. The A value here at the front needs to be 1 digit. The A value at the front must be between 1 and 9.9. The N basically indicates how big the number is. If the N is massive, it's going to be a big number. So when we have something like 3 million, the N is going to be higher than if we had something like 3,000. So getting straight into the examples, turning numbers into standard form first. 3 million, we had 3 times 10, and the best way to work this out, at the moment, the decimal point is at the end of the 0 because it's a whole number. Our new decimal place is going to be over here because it's kind of like 3.0. How many places do we need to move that decimal place to get back to the other one? 1, 2, 3, 4, 5, 6. So it's going to be 3 times 10 to the 6. Going on to the bottom one, it's going to be 4.32 because, again, that number has to be between 1 and 9.9. So it's going to be there. And again, just count the decimal places. 1, 2, 3. Now you'll notice because the decimal goes to the left this time, it's going to be a negative number, so it's actually going to be minus 3. So that's going to be that one. Standard form into normal numbers, 2.71 times 10 to the 5. The best way I like to do this, put your 2.71 in and put some zeros either side. Now, because this is a positive 5, the number is going to be getting bigger, so the decimal place goes to the right. So we want to move this decimal place 5 places and see where it ends up. Now it ends up over there, which means the number that we're going to get from this is 271,000. So we can write that one in there. When we have a negative power, 3.6 times 10 to the minus 2, exactly the same method, 3.6 in the middle, put some zeros either side. Because it's a minus 2, we're going to want to move the decimal 2 places to the left to make the number smaller. So we move it 2 places there, and you can see our new number is 0.036, just like that. Now that we've looked at normal standard form, you also need to be able to do operations with standard form, such as adding, subtracting, multiplying, and dividing. So when we're adding or subtracting with standard form, as you can see in blue, I've just written, they both follow the same method. So I'm only going to do one example with these. The powers for adding and subtracting have to be the same. Now to do this, it's normally easier to make the powers smaller. So what I mean by that is because one of our powers is 3 and one of our powers is 4, we're going to make this power become 3. Because we've made this 10 times smaller, to keep the number the same, we need to multiply this side by 10. So we can write this as 36 times 10 to the 3. Once those powers are the same, it is nice and easy. We can just keep the power the same. It's going to be times 10 to the 3. And on the left-hand side, we've got 2.4 added to 36. So it's going to be 2.4, add 36, leaving us with 38.4. But as we know from our standard form, the number at the front has to be between 1 and 9.9. We would make this 3.84 by dividing by 10. Through the same principles that we used earlier on in the question, we would then have to multiply this side by 10, making the power 10 times bigger. So our final answer for this one is going to be 3.84 times 10 to the 4. This will work with any standard form adding or subtracting. On the other side of the page, we have multiplying and dividing. This one, you'll be glad to know, is a little bit easier. You don't really have to fuss as much. And again, multiplying and dividing follow the same method, so I'm only going to do one example. 3 times 5 makes 15. And then if we look at the powers, using the indices laws that you probably know about, 10 to the power of 3 multiplied by 10 to the power of 8 means that we add the two powers together. So it's going to be times 10 to the 11, because 3 plus 8 makes 11. Again, we have the same kind of idea. This 15 at the front has to be between 1 and 9.9. So we would divide it by 10, making it 1.5. However, that means we have to multiply the other half of it by 10 to keep it the same kind of value. So this is going to be 1.5 times 10 to the power of 12. Moving away from standard form now, we have fractions. Adding and subtracting fractions, first thing we need to do is find a common denominator. And we would do that by just doing 7 times 8 is normally the quickest method. So 7 times 8 makes 56. So that is going to be our two denominators. I like to now do a method called cross multiplying. So you multiply and it kind of creates a cross. 8 times 3 would give us the top number here is 24. 7 times 2 is 14. And then once we've got that common denominator, that stays the same, and we add the top two numbers. So that's going to be 38 over 56. It's always good to look out for simplifying on your fractions as well. In this case, they're both even numbers, so we can divide by 2, and we get 19 over 28 as our final answer. Multiplying fractions, very, very straightforward. We just multiply the two top ones and the two bottom ones, leaving us with 3 times 2 makes 6, 7 times 5 is 35. And another example, you can see we just do exactly the same thing. 6 times 2 is 12, 5 times 3 is 15. Again, always look out for that simplifying if it's there. 12 and 5 both divide into 3, so we can rewrite that as 4 over 5. When it comes to dividing, you may have heard something called keep, change, flip. That is what we're going to use here. Keep the first fraction the same, 5 over 6, change that divide into a times, and flip the last fraction so it becomes 3 over 2. And then, just like the rules we learnt before, if you want to practice the multiplying, you can pause the video here and give it a go for yourself. But if not, we would just multiply across there and there. 5 times 3 is 15. 6 times 2 makes 12. Again, dividing both of those by 3, conveniently, we get 4 out of 3. Another part of fractions is using mixed numbers. Now, converting from a mixed number into a normal fraction, there is a fairly straightforward method. We take the big number, multiply it by the bottom number, and then add whatever's on top. That's going to be our top number. So 2 times 5 makes 10, add 3 we get 13, and the bottom number always stays the same, so that's just going to be 5 in this case. 43 over 7, we need to convert that into a mixed number. So how many times does 7 go into 43? Now 7 times 6 is 42, so we can write a big 6, and we also have 1 left over, so the remainder goes on top, and the 7, the denominator, stays at the bottom. Moving on to decimals, here are roughly the 3 things that you need to do with decimals. When we're multiplying by decimals, as you can see here, 0.04 multiplied by 0.2, a little trick that I like to use, however many decimal places are in the question, is how many decimal places your answer must have. So we can straight away work this out, because it has to be a 0 point, because there is decimal places there, we have to have 3. 2 times 4 makes 8, and because we need 3 decimal places in total, we just put 2 more zeros in, and that's going to be our answer. So go ahead and practice that trick first before I show you. Underline these two, we get 2 and 2, so our answer must contain 4. 4 times 12 is 48, meaning we have to have another 2 zeros in there, and that is our final answer for that one. When it comes to dividing decimals, unfortunately that trick does not work, but what we can do with dividing decimals is multiply both of them by the same thing. For example, if we multiply both 3.2 and 0.8 by 10, we just get 32 divided by 8. And the way division works, because it's all proportional, as long as you do the same thing to both, you don't need to then reverse any of that.
So 3.2 divided by 0.8 is the same as 32 divided by 8, and it just equals 4. Likewise with this next one, if we multiply them both by 100 in this case, we're going to get 40 divided by 0.5. As you can see, that is still got it in a decimal form. Makes it a little bit harder to deal with. So we're actually going to go ahead and multiply both of those by 10 one more time. So 40 multiplied by 10 is 400. Divide that by 0.5 times 10 is going to be 5. Now with a little bit of bus stop or whatever works best for you, that is going to give us 80. And that is our final answer up here as well. When it comes to adding and subtracting decimals, especially decimals where you've got different place values, it can be quite tricky to do, so I've just brought this one in to show you. The best way to do it would just be simple column addition. So 16.24, write it nice and big to give yourself a lot of room, added to 3.2. Notice how I've kept the units in the units column and the tenths in the tenths column. Add those together in a column, we're going to have 4.91. So 19.44 is our final answer. Having a look at percentages now, I've tried to split this up into the two things that are the most common when it comes to exams. So 23% of 60. Without a calculator, I would recommend going down the route of saying 100% equals 60, so 10% equals 6, and 1% equals 0.6. From there, you can kind of use building blocks to work your way up. So we're going to need 2 lots of the 10 and 3 lots of the 1, which is going to be 12 and 1.8. So we're going to have 13.8 there. If you do have a calculator for these, you'll be glad to know it's a lot easier. You can literally just write 0.23 times 60 into your calculator, and it will give you the answer straight away. So I recommend you go and double check that just to make sure you are comfortable using it. Maybe try some other examples as well, but definitely a big time saver in the exams if you know how to use that one. Using the same sort of idea, when it comes to increase or decrease by percentages, you can sit there and work out 20% of 84, but it's not the best method if you do have a calculator. Start with the original value, 84, and you want to multiply it by 1 plus the decimal form of the percentage. So in this case it will be 0.2. So in your calculator you want to write 84 multiplied by 1.2, and that will give you your answer of 100.8. Exactly the same with the decrease, but rather than adding, we would take away this time. So we start with our original value, 17.2 or 17.20. This time it's going to be 1 minus 0.36. So just to save a bit of time, that will be 0.64. Put that into your calculator and you will get 11.008. And that would be your final answer there. Next on our list, we have surds. Starting off with simplifying surds, what you want to do with these is to find the biggest square number that goes into the number, in this case 12. The biggest square number that goes into 12 is 4, so we write root 4, root 3, because 4 times 3 makes 12. Now we know the square root of 4 is 2, so that would quite simply just be 2 root 3. Root 72, a lot of you will look at it and think that the biggest square number that goes into it is 9. However, if you go a little bit bigger than that, you'll find 36 also goes into it. So we can write this one, root 36, root 2. Now the square root of 36 is 6, and we just rewrite that as root 2. Now a challenge for you, let's say you do write this as root 9, root 8. Try and simplify this to get the same answer. It will work, and I just want you to know that there's more than one way that you could get to these final solutions. Finally, rationalizing the denominator. This first one is more towards the higher end of foundation, and the other one is definitely higher. So if you do foundation, don't worry about the bottom one. 3 over root 5. Rationalizing means to get rid of the surd on the bottom of the fraction. So what we want to do here is multiply by our surd on both top and bottom, because as a fraction, whatever we do to the top, we have to do to the bottom. So we're going to have 3 root 5 over 5, just like that, because root 5 times root 5 makes 5. Now, for this bottom example here, what we do, we want to multiply by something called the conjugate of the bottom surd. In this case, we're going to have 1 minus root 3. Now, imagine this as like double brackets, and we just want to expand those double brackets. So on top, we're going to have 2, and then 2 times minus root 3 is minus 2 root 3. And root 3 times positive 1 is going to be plus root 3. And then finally minus 3, because root 3 times root 3 is 3. And on the bottom, we're going to have 1. The middle terms cancel out, which is the whole point of making them positive and negative. And then finally minus 3 on the bottom. So our final result, we are going to have minus 1 minus root 3 over minus 2. And that is our final solution. I recommend trying a few of those because that's a very common, difficult question at higher. Indices laws next. Anything to the power of 0 is 1. So if you have 3e all to the power of 0, that's going to equal 1. Multiplying, an example would be to simplify a cubed times a to the 5, that is going to be a to the 8. Dividing, a to the 8 divided by a to the 6 is going to be a squared, so we take away the powers when we're dividing. Brackets would be something like a to the 3 all to the power of 4, and that would be a to the 12, so we multiply when we have brackets. Fractional powers, so if it's a to the half, that is going to be the square root of a. So 25 to the half equals 5, because the square root of 25 is 5. Another example would be 8 to the power of 2/3. Now if we have a 3 on the bottom, we want to cube root our number, and then because of the 2 on top, we square that final answer. The cube root of 8 is 2, so 2 squared is equal to 4. When we have negative powers, we want to write, for example, 2 to the minus 3. The negative actually reciprocates our number, so instead of 2, it's going to be 1 over 2. The power will stick with that 2 and become 2 cubed, so our final answer is 1 over 8. Estimation. Now, as you can see in the red box, always estimate to one decimal place or one significant figure unless it's stated otherwise. In this example, we're going to look at 3.29 is going to become 3, 38.2 is going to become 40, final answer 120. Root 63. Now, we could put this to root 60, however, we all know that 64 would be a better answer because that is a square number. Divide that by 4.25 becomes 4, root of 64 is 8, 8 divided by 4, final answer is 2, and finally we would do the square root of 50 over 0.5. Now 50 divided by a half is going to be 100, and the square root of 100 is just 10. Recurring decimals into fractions. We let x equal our recurring decimal, so 0.4 recurring in this case. We then want to multiply that by 10, which will in turn move the decimal place one place to the right. So we have 4.4 recurring. Now as you can see, both of these decimals are the same, so if we take them away, they're going to cancel out, leaving us with 9x because 10x take away 1x. 4 take away 0 ultimately is 4. So x equals 4 over 9. That's our first answer. Now if you're doing foundation, I wouldn't worry too much about the next one. We would do exactly the same process. 0.367367 and so on. Multiply by 10, you'll find that we don't get the same decimal places. So just to speed things up, I'm going to multiply this one by 1,000, which will move it 2 more places up from the 10. Leaving us with 367.367, and so on. Now you can see that the decimal places between the first one and the third one are the same. So if we take those away from each other, we're going to have 999x equals 367, leaving us with 367 over 999. And that is the number topic all done. Going into algebra now. Here is a list of all the topics I have broken algebra down into. So starting off with simplifying algebra, a plus a plus a, 3a. If ever you struggle with adding and subtracting with just the letters, imagine the letters as objects. 1 apple plus 1 apple plus 1 apple is 3 apples. That's always helped me. 6a plus 3a, again 6 apples plus 3 apples is going to be 9 apples. A plus b plus c, now those are different objects or different letters. So you ignore them because we cannot simplify that any further. 3a minus 2b, add 6a. Now look at the 2 you have. 3a plus 6a is 9a, and then the minus 2b just stays. X multiplied by x is x squared. Again, if you're unsure, put numbers into that. 2 times 2 is 2 squared, so it's exactly the same thing. 3x times 6y, 18xy. 12xy times 3y, 36xy squared, because we have two y's. And then x divided by y, we would just write that as x over y to simplify it. Substitution. Calculate the following when x is 3 and y is minus 5. So 2 lots of 3 squared minus 3 lots of minus 5. Now 3 squared is 9, so 2 times 9 is 18. And then take away 3 times minus 5 is actually going to be minus 15. So 18 minus minus 15 is going to be 18 add 15, which is going to equal 33. And then on this side we have 4y squared add 10. So 4 lots of minus 5 squared add 10. Now minus 5 squared, minus 5 times minus 5, is actually going to be positive 25. Add 10, so we have 100, add 10, which is 110. Expanding brackets. I like to refer to something called the claw method. Hopefully you've heard of it, but that's what I'm going to be using here. So we create kind of like a claw over our bracket, so I'll do it for all of them. And again, please, if you feel confident enough, give these a go before you see me do them. 3 multiplied by 2x is 6x, 3 multiplied by 1 is 3. 6x times 2, 12x, minus 6x times 3x is 18x squared. Minus 7y times minus 2x, we know that's going to be positive. 7 times 2 is 14, and then the letters will be xy. And again, we have a negative times a negative, so it's a positive. 7y times 3 is 21y. Expanding double brackets is slightly different. We use a double claw method here. So we do a claw on the top, x to x, x to 7, then 3 to x and 3 to 7. That one leaves us with x squared, add 7x, add 3x, add 21. Combining those two middle terms, we're left with x squared plus 10x plus 21. Doing the same for the bottom one, slightly harder because we have an x coefficient in this case. So 2x times 3x is 6x squared. 2x times positive 2 is plus 4x. Then we have a minus 3x and a minus 2. Again, combining those middle terms, we're left with plus x minus 2. And that's our final answer there. Now we have the opposite of expanding. So we're putting them back into brackets now. What we want to do here is scan along and look at the numbers. Do we have any common numbers that we can take out? And in this case, we have a 2. So we do 2, open up the bracket, and inside it, what do we have to multiply to get to the original thing? So multiply by 2 to get 2x would be an x, and then multiply 2 by something to make 10, that something would be a 5. You can always check these by expanding them back out again using that claw method. 15xy minus 6x squared. So straight away we can take out a 3, but this time we can also take out an x because it appears at least once in both. Open up our bracket, we need 5y to get back to 15xy, and a minus because there's a minus in the middle, and then 2x on the other term. Now for quadratics, we want to open up a double bracket just like the double brackets before. Because we have an x squared at the start, we would have to do x and x here. And because we have all positives, it's going to be 2 positives in this case. If you're looking for a longer video on how to factorize quadratics, I have made plenty of them. If you have a look on my channel and search it up, you will find it there. We want to find 2 numbers that multiply together to make 20 and add together to make 9. So I like to make factors over here. We have 1 and 20, 2 and 10, 4 and 5. Of those numbers, which pair adds together to make 9? As you can see, the 4 and the 5. So that is going to be our final answer. And I'll leave it as a challenge to you guys to do the double claw method on that double bracket to see if you can get back to the question as well. For the bottom one, this is definitely a very high level foundation, if not low higher question. So we want to open up that double bracket again. This time, notice we have a 2x squared. The only way to get 2x squared would be having a 2x and an x. Again, it's all positive, so we put 2 pluses there. We again want to find 2 numbers that times together to make 15. 3 and 5, 1 and 15. In this case, whatever number goes here, when we expand it, is going to be multiplied by the 2.
So we have to take that into account. So in this case, it's going to be the 3 goes there and the 5 goes there. Because when we expand that part of it, it's going to become 6x, and this one is going to be 5x, which when we add those together, makes 11x. Nth term. Linear nth term is something that everyone should be able to do really comfortably. So hopefully this little example will help. If not, the first thing we want to do with nth term is find the difference between the terms. As you can see here, each time we're adding 3. So we know it's going to be 3n. What we then want to do is write down the 3 times table to compare. 3, 6, 9, 12, 15. Draw a line underneath, and we want to take the top one away from the bottom one. 2 take away 3 is -1. 5 take away 6, -1. 8 take away 9, and you get the pattern. So our final answer here is 3n minus 1. Quadratics are slightly harder. We still want to find the difference, but what you'll find is the difference is not the same. So we're adding 4, we're adding 8, we're adding 12, we're adding 16. So we look to our secondary difference, and you can see it's all going to be 4. Now what we then do is we half that number, and that's going to be our n squared coefficient. So this is 2n squared. We then want to write out what 2n squared is. So it's going to be the square numbers, but doubled. So 2, 8, 18, 32, and 50. Again, we do exactly the same thing. We take them away from each other. 1 take away 2 is -1. 5 take away 8 is -3, -5, -7, and -9. From here, a lot of people get confused. Whatever we did up here is the exact process you continue down here. So we find the difference, and you can see it's taking away 2 each time, which means it's going to be -2n. And then if we write down the -2 times table, -6, -8, -10, take them away from each other. -1 minus -2 is the same as -1 add 2, which is 1. And you'll soon find that all of these are a positive 1. So our final answer here, 2n squared minus 2n plus 1. Just like that. There are 3 types of sequence: arithmetic, geometric, and Fibonacci. I've written a couple little bullet points of each of them, as you can see here. So have a read of those, pause the video, make some notes, and I've also underneath got some examples. So for this first one, the rule is just adding 2, and this one we're taking away 7. Arithmetic is always adding and subtracting between terms. Geometric is timesing and dividing between terms. So the next term here, we would just multiply 81 by 3, that would be our rule. And this one, it's a bit of a tricky one, but we're dividing by -2 each time, or multiplying by -1/2 if you want to look at it that way. Fibonacci, we take the sum of the previous 2, add them together to make the next number. So you can see 1 add 1 makes 2, 1 add 2 makes 3, 2 add 3 makes 5. I'll represent that with 2 add signs, and it's exactly the same rule for the bottom one as well. Any Fibonacci sequence you find will be following this same sequence. The next thing you need to know is the difference between equations, expressions, and identity. All I have is just a quick exercise where we just have to match the pairs. Pause the video and give this a go for yourself before I show you the answers. An expression is where it doesn't have an equal sign. In English, this might just be like a clause. So this is going to be the bottom one. An identity is where it works for every single value of x. Now that's going to be the middle one, and it's often represented by this triple equal sign here, so always look out for that. And obviously the equation only works for certain values of x. In this case, just one value of x. Next we have solving equations. So obviously solving equations, you could have all sorts of examples. I've tried to pick examples from the main 4 categories to try and get as much variety as possible. But the main idea here is to be really confident with rearranging. So what we would do first is we would take away 3 from both sides, leaving us with 2x equals 10. And then we want to divide by 2, and this will be x equals 5. And you can always double check this by substituting the answer back into the question to make sure you get the right value. So I recommend you go and do this just to make sure you understand. With the next one, the first thing we want to do is expand the bracket. So we would do 3x minus 12 equals 2x plus 6.
and I recommend always writing a new line for every new thing that you do. Now with this next part, we are going to take away 2x and add 12 in the same go. So this will move this one over here and this one over here, leaving us with x equals 18. And that is already our final answer. This is more going on towards the higher level stuff now, but if you're doing foundation, I'd still recommend learning this one. We want to do something called cross multiplying basically. So we multiply the 3 up there, the 2 up there, leaving us with 2 bracket 2x plus 1 equals 3 bracket 3x minus 4. Just like what we did before, expand the brackets, 4x plus 2 equals 9x minus 12. Take the 4x across to the right hand side and add 12 to the other side, leaving us with 5x equals 14. So x is going to be 14 over 5, or you can convert that into a decimal as well. Finally, something slightly different is solving quadratics. Now, we recently learned earlier in the video how to factorise quadratics, so I'm just going to go ahead and do that. If you're unsure, go back and re-watch the factorising quadratics to see how I got to this point. From here, we need to think, what does x have to be to make this whole thing 0? X could either be minus 3 for this bracket, or if we want to make this bracket 0, it's going to be minus 4. A little shortcut for that is it's always the opposite of whatever is in these brackets here. So we have 2 pluses, so the answer is both negative. Next on our list is changing the subject / rearranging. This kind of is very similar to the solving equations, but sometimes can be a little bit harder because it has a couple more letters. So for this one, we want to make v the subject. So what we would do straight away is take away 1. T minus 1 equals v over 4. The way I always look at it is I always want to get rid of everything that isn't attached to the v first. So you can see here the 4 is kind of attached to the v by the divide sign. So we can move the plus 1 quite easily just by taking away. And then from here, because it's v divided by 4, we would just multiply that by 4. So we get v equals 4 lots of t minus 1, just like that. Now this is very much a higher question, the second one. What we want to do for this is we want to first of all get rid of the fraction, so we multiply this up here. So we have y bracket x minus 1 equals 2 plus x. We then expand the bracket, yx minus y equals 2 plus 1. Now here a lot of people often get stuck. We want to get the x's on one side, the numbers on the other side. So we're actually going to take away x and add the y to the other side, just like that. Now we can factorise and have x bracket y minus 1 equals 2 plus y. So x equals 2 plus y over y minus 1. If you're doing higher and aiming for a level 6 and above, I would highly recommend learning this method. Practice a couple questions because it's a very high rewarded, difficult rearranging question. But a lot of them are very similar to that method if you get one like it. Next is simultaneous equations. There's 2 different methods for simultaneous equations. We have the elimination method, which is the most common one, and also the substitution, so I will do an example of each. The way we want to solve simultaneous equations by elimination is making either the x's or the y's the same. In this case, I'm actually going to make the x's the same. I would do that by multiplying this one by 2 to get the 2 x's so that we can cancel them out later. So I'm just going to rewrite this one and double it all underneath. So 2x plus 4y equals 16. And to cancel the 2 x's, we're actually going to add them together because minus 2x add 2x makes 0. This will leave us with 5y equals 15, so y equals 3. Now what we then do is we have to use the y equals 3, substitute it back into one of the equations to get the other answer. So I'm going to use the top one. So x plus 2y, but we know y is 3, equals 8. So x plus 6 equals 8. So we know from there that x must be 2, and that is our 2 solutions. Now for substitution, this is only a higher question, so if you do foundation, don't worry about it. A little bit harder, we actually need to use the fact that y is equal to this and substitute that into there. This will give us x squared plus x minus 1 squared equals 25. We need to expand out that double bracket, giving us x squared minus 2x plus 1 equals 25. And 2x squared minus 2x, and then we're going to take away 25 as well, giving us minus 24 equals 0, just like that. Now what we can do here, always look out for this as well, because all the coefficients are multiples of 2, we can divide by 2, giving us x squared minus x minus 12 equals 0. Again, just like when we did solving quadratics, it's exactly like that. So x is going to equal minus 4 and positive 3. So our 2x values are going to be 4 and minus 3. Now we're not done just yet because we also have to work out the y values just like before. So if we sub them into this easier looking equation, we can see that y is going to have to be 3 because y is x minus 1, and y is also going to have to be minus 4, and they are our pairs of solutions. Next we have functions. Again, the one in the top left is more foundation level, and then the other two are higher, so again, foundation, don't worry too much about this. If f of x is 3x plus 4, what is f of 5? A lot of people confuse this and find it more complicated than it actually is. All we have to do is wherever we see an x in here, we replace it with a 5. So it's going to be 3 lots of 5, add 4, which is 19, because 3 times 5 is 15, add 4, 19. Do the same again for the bottom one. We just sub in minus 1, and that's going to be positive 1 as our answer, because minus 3 add 4 is 1. Now for composite functions, we kind of have to substitute one function into the other. So f of x is that, g of x is that. I'm going to label these two 1 and 2. So f of g of x, we need to substitute g of x into f of x wherever we see the x. So because g of x is just x squared, we're just going to substitute x squared wherever we see x. So it's going to be 3x squared, add 2, just like that. Now using that example, see if you can work out g of f of x before I tell you the answer. Hopefully you've had a minute or two to just think about that, but this time we need to sub f of x into the g of x. Now because g of x is just x squared, we're going to take the whole of f of x and square it, and that is simply our function. Composite functions again can have all sorts of forms, so I highly recommend trying lots of different examples of those to get the full idea of it. Inverse functions, on the other hand, is basically do the function but backwards. So there's two ways of doing this. For a function like this, it might be easier to think, well, we take our x, we are squaring it first, we are then multiplying it by 2, then we are adding 3, and that is our f of x. So if we need to do f to the minus 1 of x, or the inverse of f of x, we would start with our x and just do the opposite every time. So take away 3, divide by 2, square root it, that's going to be the inverse. So if we turn that into an actual function, f to the minus 1 of x is going to be equal to x, take away 3, divide it all by 2, and then square root the whole thing, just following what we worked out in that order. Now the way you may have learnt it in schools is to set the f of x equal to y and then rearrange it for x. I would highly recommend learning that method as well, because sometimes this method that I just taught you is a little bit harder to do when the function is a bit more complicated, but this will work for most functions. So it's a good visual way to understand it quite easily. So iteration is next. Most of the time this will be done with a calculator, so I'm going to show you how to use a calculator effectively to answer these questions. If you don't have a calculator in the exam to do these, they're often going to be quite easy ones anyway. This is our equation that we have to use to work out our values. Put in your calculator, press 1, because x1 is 1, and then press equals, and that will save your ants button equal to 1. Then what we're going to do is we're going to put in our calculator 4 minus ants cubed over 6. If you press it once, your x2 is going to be a half, and that is your x2 value. If you press it again, it will give you the x3 value. That is going to be 31 over 48, and we need to find x4, so we press it one more time, and we get a value of 0.62177, and so on. What you'll often find is if you keep pressing equals, the answer will settle at a certain value, and this is one of the uses of it. But as I said, as long as you can do the process, you'll be absolutely fine with iteration. And that is the end of the algebra. Following on from algebra, we have all the graph topics. Starting off with straight line graphs, the simple y equals mx plus c. It is crucial that you are confident with mx plus c, whether you're doing foundation or higher. The m always represents the gradient, and the c always represents the y-intercept. I will get on to more about what these mean in a minute. A common exam question when it comes to straight line graphs is where you get given the equation, you get given a range of x values, in this case it's from -2 to 2. You have to then substitute those x values into the equation, into the x, and it will give you the corresponding y value. If you've done any form of past papers or practice papers in your life, you would have seen these before. What that then gives us is coordinates, and we have to then go and plot those coordinates. So as you can see, at 2, we have the coordinate 3, so I'm going to plot that one there. 1, 1, 0, -1, 1, -1, -3, and -2, -5. As you can see, that creates a nice straight line, and we can go and complete that. Now, going back to earlier, the gradient and the y-intercept of this line, the gradient is 2, because if you were to choose a point, let's say this point here, if you go across 1 unit on the x-axis, we have to go up 2 units of the y-axis to get back to that line. So that is how that works. And the y-intercept, you can see, where does it cross the y-axis? Now you can see this coordinate here is at -1. That is why that is a -1 on the end of the equation there. That sums up all of the straight line graph stuff that you will need to know for the most part. Finding roots of quadratics. This is at the higher end of foundation. Some of you may not have heard of what roots are before. Roots of the equation are where it crosses the x-axis here. Now at the x-axis, on this line, y is equal to 0. So what we actually want to go ahead and do is let y equal 0 here, and this is where it might become a bit more familiar. We can set it up and solve it like we would a normal quadratic. We've done plenty of factorising quadratics in this video so far, and even solving quadratics. So I'm going to go ahead and input the numbers in straight away. We have -2 and +4 equals 0. So we know our x values must be at +2 and -4. And as you can see on our graph, that is +2, that is -4. So it's a very useful method to help draw out a quadratic graph as well as just find out the roots of it. On to our next point, the harder graphs. Luckily with these you don't need to know as much as you do compared to quadratics or straight line graphs, but there are certain equations you need to be wary of when it comes to identifying them and noticing patterns to do with them in exam questions. So this first one here, I've given us a little hint, creates a kind of S type shape, and this would be the graph of y equals x cubed. So a cubic graph creates this shape. The next one we have always has a y-intercept at 1, never becomes negative, and it's something called an asymptote. An asymptote is where it goes alongside the line, y equals 0, but never actually meets it, so it doesn't actually cross it. This exact example is y equal e to the x, or 2 to the x, or 3 to the x, anything like that, often called an exponential graph. And finally, we have the graph of y equals 1 over x. Now, obviously in an exam, there could be modifications of these. It would be impossible to cover all the options in one little video. But the best practice for that would just be through past papers and seeing different types of questions where they involve these. Completing the square. So as you learnt from before, we know how to calculate the roots of the equation now. We also need to work out something called the turning point. The point where it goes from going downwards and starts going back up again. Now there's a very specific method we do to do this. So we want to open up our bracket, we half this value here, so if it's 4, we put 2, and then it's going to be 2 squared. The plus 10 comes down, and we do the negative of the square of this value. So it's 2, so 2 squared is 4, so it's -4 plus 10. Then rewriting this underneath, -4, add 10, if we simplify that down, is going to be +6. So the turning point, this point here, is going to have the coordinate of -2, +6. So it always stays the same as this one, but it's always the opposite of whatever that sign there is. The general form for completing the square is x plus a squared plus b, where the coordinate is -a and b, for some of you that prefer to write general formulas for things. Next, we have the quadratic formula. The quadratic formula, first of all, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I would highly recommend getting comfortable with this equation, understanding how to use it, and first of all remembering it. This is used when we aren't able to factorise the quadratics to solve them. So looking at this, what numbers multiply together to make 6 and add together to make 8? Now we've got things like 3 and 2, 6 and 1, but none of them make 8. So this is where we'd use the quadratic formula. The letters A, B and C come from the coefficients of the equation. So A would technically just be 1 in this case, B would be the 8, and C would be 6. So let's take our equation and substitute in those values. We're going to have x equals minus 8 plus or minus the square root of b squared, which is 64. I'm just going to go ahead and do that. And then 4 times a times c. So 4 times 1 times 6 all over 2a, which is just 2. So x equals minus 8 plus or minus the square root of 64, take away 24, is going to be 40 over 2. And believe it or not, that is just your answer. You can take that, put that in your calculator, and it will give you the value that you need. If you're doing higher, you can simplify the surd and maybe get your answer that way, and you'd leave your answer as a surd if it was a non-calculator paper. But if you do have a calculator, chuck the whole thing in your calculator, it will give you the decimal value anyway. Next, we go on to function transformations. So if I quickly draw out a quadratic graph, it doesn't have to be quadratic, but I'm just going to choose that. If we have the f of x plus a on the outside of it, it moves up a spaces. So say it was f of x plus 2, we would pick up our graph and redraw it 2 spaces up instead. You can have a read through all of these, make sure you make a note on all of them and get some practice questions in at another time as well. As a little rule of thumb, if the a value is outside the bracket, so the first one, the fourth one, and technically the fifth one, it always affects the y direction, the y-axis. So if it's outside and we're adding, it moves up a spaces. If it's a multiple on the outside, we stretch it by that much. And a reflection in the x-axis is technically just a vertical reflection. So it's all relating to vertical movements or y-axis stuff. And it's exactly what you'd expect. So if it's plus 2, you'd move it up 2 spaces. When it's inside the bracket, so f of x plus a inside, the third one and also the bottom one, it all affects the horizontal direction or the x-axis, and it's the opposite of what you'd expect. So if we have a plus a, in the horizontal direction, that would normally indicate a move to the right, but in this case it is a move to the left. Likewise, if it is ax inside, we would expect that to stretch it, for example by a factor 2, but that would actually half it. So it's always the opposite of what you'd expect. It's a tricky topic only for the higher students, so I would take a bit of time to understand that if you can. And finally, for the higher students, again, the circle equation. Fairly simple equation. X squared plus y squared equals r squared. So for example, this particular circle would be x squared plus y squared equals 9. Because as you can see, the radius is 3, and 3 squared makes 9. There's not a lot more to say about these. That is pretty much all there is to it. And that sums up all of the graph content that you will need to know. So moving on to actually our smallest topic, the ratio, proportion and rates of change. I have split them up into these 6 subsections. Starting off with unit conversions, you need to know the basic unit conversions, and then those doing higher need to be comfortable converting between meters cubed, centimeters cubed and all that kind of stuff. So 230 centimeters, well, we know there's 100 centimeters in 1 meter, so that's just going to be 2.3. 4.67 litres is 4670 millilitres, because there's 1,000 millilitres in a litre. Before I go on to the next question, there is something that you should know. So milligrams to grams to kilograms. If we're going from milligrams into grams, we divide by 1,000. If we're going from grams to kilograms, we divide by 1,000. If we go the opposite way, we are multiplying by 1,000 instead. So always remember, kilo, the word, means 1,000, because 1 kilogram is 1,000 grams. So 6,000 milligrams, we actually want to divide by 1,000,000 in total. That's going to be 0.006 kilograms. And finally, 23 millimeters is going to be 2.3 centimeters. Now moving on to meters squared and centimeters squared, the best way I like to model this one is starting out with a square, because 1 meter squared is not equal to 100 centimeters squared, unfortunately. If we have a 1 meter by 1 meter square, the area is going to be 1 meter squared because 1 times 1. If we convert that into centimeters, it's now 100 by 100. So 100 times 100 is 10,000 centimeters squared. So 25 meters squared is actually going to be 250,000 centimeters squared, because we do this times by 25. Now, when we're talking about cubed, let's make this square 3D and turn it into a cube. Now, instead of just 1 by 1, it's 1 by 1 by 1. So that's going to be 1 meter cubed. Again, if we convert that into centimeters, that's now 100 centimeters by 100 centimeters by 100 centimeters. So all in all, that's actually going to be 1,000,000 centimeters cubed. This method will help you, so remember it. Next we have ratios, and ratios can come in all sorts of shapes and sizes with exam questions. So once you learn this basic stuff, practice lots of exam questions to get the grips with things. So simplifying ratios, first of all, we just want to find a number that goes into both. I can see straight away that 8 goes into these, so that's going to simplify to 8 and 3. Just like fractions, you just divide by that number. This one is 7, so we're going to have 3 to 2. Share 4 to 8 in the ratio 5 to 3. The way we're going to do this is we take our ratio and we add it to make 8. Then think of this as 8 parts of the ratio in total that we need to share 48 in. So 48 divided by 8 means we have £6 per unit of the ratio. So 5 times 6 and 3 times 6 is going to be 30 and 18. And that is going to be our final answer. And finally, combining ratios, a bit more towards the higher side of things. So the ratio of circles to squares is 2 to 3. And the ratio of squares to triangles is 4 to 1. If there are 16 circles, how many triangles are there? So the thing we want to do here is recognise which of our parts of the ratio are the common one between the two. So you can see here that the squares are the common thing. So just like with fractions, we want to find kind of like a common denominator. 3 and 4, we can both get that into 12. So to get from 3 to 12, we've multiplied by 4. So we're going to do the same on the left-hand side with the circles. Multiply that by 4. But on this side, we've multiplied by 3. So we're going to have to do the same to the 1. So that is going to be our ratio. And if there are 16 circles, how many triangles will there be? Now, if 8 is the ratio, and that represents 16 circles, then each unit of the ratio must represent 2 shapes. So the number of triangles must be 6, because 3 multiplied by 2 would get us to 6. Direct proportion next. The most common type is these word problems we have on the left. If 12 books cost £84, how many will 7 books cost? I always like to use these little equations for this because I find it really useful. So 12 equals 84. So 1 would have to be 7. That means 7 would have to equal £49. What do you assume? This is a very common follow-up question for a lot of these proportion questions. We always assume that the books would cost the same. Because some of those books could cost £10, some of those books could cost £5. But we don't know that information, so we're going to have to assume they're all the same. And finally, more for the higher students, is the algebra kind of proportion. So y is directly proportional to x squared. So we want to rewrite this as an equation by saying y equals kx squared, introducing that scale factor. If y equals 20 when x is 2, so we can let this equal 20 and this equal 2, then first of all we need to work out k. Now 2 squared is 4, so k must equal 5. We can then use that to rewrite this top equation here, leaving us with y equals 5x squared. And then using that scale factor knowledge now, we want to work out what x is when y is equal to 30. So we again let y equal 30 by substituting that in, equals 5x squared Dividing by 5, we know that 6 equals x squared, so x is going to equal the square root of 6, and that will be our final answer. Very similar to direct proportion, but this time inverse proportion. So as one goes up, usually the other will go down, unlike direct proportion. So if it takes 3 hours for 2 taps to fill a pool, how long will it take 3 taps? So 3 hours equals 2 taps. Now, first of all, just like before, we need to work out how long will it take 1 tap to fill up this pool. A lot of people would divide the answer by 2, because we've divided by 2 here. But realistically, if it takes 2 taps 3 hours, is it going to take 1 tap 1.5 hours? No. So with inverse proportion, we actually want to multiply on the other side, because it's going to take twice as long if we've got half the taps. So therefore, if we've got 3 taps, we're going to be multiplying by 3 on this side, and so we're going to be dividing by 3 on that side, and our answer is going to be 2 hours. Again, what do we assume, just like the last question? All the taps work at the same rate. That is our assumption. A very, very general 1-mark question following on from one of these. So be on the lookout for those questions. Y is inversely proportional to x. So very similar to the other algebra one we just did. We're going to say y is, because it's inversely proportional, we do 1 over x. And again, converting that into an equation, we introduce that scale factor k again, and we put that on top of the fraction. If y is 10 when x is 3, so again we introduce the y and the x as the numbers, equals 3, that leaves us with k being 30. That's the only solution for that one. So again, we go back to here, we introduce that k into the equation, 30 over x, and we want to work out what x is when y is 5. So if we substitute 5 in here, 30 over x, x has to equal 6 for that to work. So that's going to be our answer. Compound interest next. Simon deposited £3,000 into an account with 3% compound interest per annum. How much is it worth after 4 years? So this is going to be an increasing one. So the money is increasing every time. Now you're given the equation for this one actually. So it's going to be the original value multiplied by, now I like to say 1.03 because 1 is the base value and we're adding 3%, so 0.03. And we do it to the power of how many years we have. All you have to do is pop that in your calculator and it will give you the answer. And the final answer for that one is £3,376.53. And even though it doesn't specify about decimal points, we're dealing with money. That would normally be to 2 decimal places because of pennies. So use that as a general rule when you're doing money calculations. Now for this one, it looks very similar, but it is slightly different because this is a decrease by 5% each year. So again, we start off with our original value and we multiply it. Now I said before 1 is our base value, but because this time it's going down, we actually want to subtract 5% from 1. So this time it's going to be 0.95. So technically what I've done is 1 take away 0.05 to get that one. And then we do that to the power of 5. Again, put that in your calculator, and your final answer is £619.02. Next, we have the different rates on a graph. So this is mostly going to be for the higher students, something you can also use in GCSE physics quite a lot. So calculate the speed at 5 seconds. What we're going to want to do here is locate 5 seconds on the graph. We can see it's about there. And we want to draw a tangent to the graph at that point. So using a ruler, nice straight line. Now ultimately, we want to just find the gradient of that line. So the way to do it with these ones is find 2 nice coordinates. So I'm going to pick there and here. As you can see, they pass through nice places, nice even numbers. And to get the gradient, we want to do the change in the y over the change in the x. You can see the change in the y is going to be the 170 up here. I'm looking across here to the y-axis, by the way. And at the bottom it's going to be 50. So our change in y, 170 take away 50 is 120. And our change in x, you can see if we bring these two down, that's at 2, that's at 11. So that's going to be 9. And simply put that in the calculator, and we get roughly 13.3. If you ever forget how to do that, remember that speed equals distance over time, and technically what we're doing, because the y-axis is distance, the change in the y is the same as distance, and the change in the x is the same as time because the x-axis is time. And your units are always going to be meters per second for speed. And that is all of the ratio, proportion, and rates of change done. The next section is all on geometry and measure. As you can see, this is a fairly big topic. I've tried to keep the number of subtopics down to a bare minimum, but I still have 13 because there is quite a lot to cover in this bit. Starting off with 2D shapes, it's crucial all levels of maths can identify and name all the different types of 2D shapes. So there are 4 different types of triangle. We have right angle, because it has a right angle. Isosceles triangle. Be careful on the spelling of that one, it can be a bit tricky. Equilateral triangle, where all the angles and all the sides are the same. Isosceles triangles as well have 2 angles that are the same and 2 sides that are the same, as you can see, as I've drawn on there. And when you've got a triangle that has nothing the same, that is called a scalene triangle. Quadrilaterals, we have the common square and rectangle, where all the right angles and the common sides have been labelled. A slanted rectangle is called a parallelogram, and the one where you have the parallel sides like this is a trapezium. A slanted square is called a rhombus, and finally a kite, where we have line of symmetry straight down the middle, 2 opposite angles that are the same, and the sides that are the same length as well. Finally, the polygons. A 5-sided shape is a pentagon, 6-sided shape is a hexagon, a 7-sided shape is a heptagon, octagon for 8, octopus, octagon, easy to remember. 9 and 10 I wouldn't say are that important, especially if you're only doing foundation. For the hires, it could be good just to have a rough idea of what they're called, just in case it pops up. But that is all of the 2D shapes that you need to know for now. Next we have area and perimeter. So I've made a little exercise here where all we're going to do is just match them up, match the pairs. So starting off with circle, again pause the video and give it a go for yourself first if you want to try it. But circle, we have pi times radius squared. Rectangle, base times height, square, also base times height. The trapezium is a plus b over 2 times the height, where a and b are those parallel sides. And the triangle, half the base times the height. So hopefully you know most, if not all of those already. And here we're asked to work out the perimeter. Now, the perimeter is the distance around the outside of the shape. But what you'll notice is we're actually missing 2 sides at the moment. So we know that this one is 13 and this one is 7. So this one here must be 6. And using a similar theory, this one's 12, this whole thing's 8. So this little one must be 4. So adding all of those up together, we have 13, add 12, add 8, add 7, add 6, add 4, all together equals 50 centimetres, just like that. Going on to the angle rules, it is crucial again that you learn all of these. So on a straight line, it adds up to 180 degrees. So to work out A, we would do 180, take away 136, and that would get us 44 degrees. The angles around a point add up to 360 degrees. So we would do 360, take away 148, take away 62, and that leaves us with B to equal 150 degrees. Now finally going on to polygons, it gets a little bit tricky here. But we have 180 degrees in a triangle, as we know. And a lot of you probably know that in a quadrilateral we have 360. But as you increase the number of sides, the angles don't stay the same. So the general formula, for those of you that have heard of this before, is n minus 2 multiplied by 180, where n is the number of sides. An easier way that I think to look at it is split your shape up into multiple triangles. So imagine we turn the quadrilateral into 2 triangles. We know that triangles are 180, and because of this, when we add them up, they equal 360. If we do the same for this pentagon here, we can split it up into 3 triangles, so 180, 180, and 180. if we add those up, we know that the internal angles add up to 540. A very, very useful trick I've always used going through GCSE Maths and beyond. And that can be scaled up to 6, 7, 8, 9, 10-sided shapes, and so on. More angle rules, but with parallel lines. So here, commonly known as a Z angle, do not call it that in your exams. We want to call that an alternate angle. And these angles are equal to each other. Likewise, we have the F shape in the middle here. Again, do not call it that. We want to call this one a corresponding angle. These two angles highlighted in blue here and here are going to be equal to each other again. It does help quite a lot because they look quite even, so that's always a good thing to notice. But yes, just remember Z and F ones, alternate angle and corresponding angles are equal. And finally, what most people remember as a C angle. Now, looking at those two, yes, some could say they look fairly similar, but they don't actually look equal, to be honest. They add up to 180. These have a fair few names, but the most common one is called co-interior angles. So always refer to these three as those three things, and do not mix them up with the letters. Volume. Calculate the volume of the compound shape. Now, I've purposely made this tricky just to cover as many different shapes and as many different scenarios in one example here. So whenever we see a compound shape, the first thing we want to do is break that up into as many different shapes as we need to be honest. So what I'm going to do here is split it up twice. So we have a rectangle, another smaller rectangle, and also a semicircle. Now what you'll notice about this one is it's a prism, because it is a certain area, the cross-sectional area, and then it's just being pulled backwards. So that's going to be very useful in calculating the volume. So if I label each of these 1, 2, and 3, I can then do the calculations on the right in a nice, neat way. And again, I would recommend doing this in an exam, just to make it really clear for the examiner. They are much more likely to give you the full marks if they can understand and read absolutely everything, if it's presented nice and neatly. So for the first rectangle, we can bring this length forward. We know that is 4. So simply 4 times 10 is 40. Side number 2, we know that the width of that shape is 5 and the height of it is 6. So simply 6 times 5 is going to be 30. And then finally, for this half circle kind of thing, we know the radius is going to be 3 because the diameter we're given is 6. So it's actually just going to be pi times 3 squared. But because it's a half circle, we're then going to divide that by 2. So 9 pi. And then we want to do 9 pi divided by 2, which we'll just keep at 9 over 2 pi for now. So that's our 3 shapes. We need to add those together. So keeping this in terms of pi, it's going to be 70 plus 9 over 2 pi because I've added these two together. And then just like I said before, we work out the area of the cross-sectional surface and then we multiply it by how far it's been pulled back. So the depth here is going to be 9. So we want to do 9 multiplied by this. And our final answer, if I just put all of that in the calculator, gives me an answer of 757.23. And it's all in meters. Volume is going to be meters cubed. So that is our final answer there. I hope that helped. Next we have the surface area. And again, I've chosen a fairly difficult shape just because this will cover most scenarios. So whenever it comes to surface area, straight away, I like to label all my surfaces that I have. Now in this one, there's only 3 of them. So we're going to go 1, 2, and 3. Now I'm going to give this one 1. The surface underneath the circle is going to be 2, and the big curved one is 3 because we need a bit more space for that. What you'll notice is 1 and 2 are actually both the same, and we would just do 5 squared times by pi because pi r squared is the area, and again just leaving that in terms of pi, 25 pi. Now the second one is the same surface just on the bottom, so that makes that nice and easy. Now for shape number 3, we have a curved surface area here. And if we were to draw the net of this shape, we can expand it out like this. Imagine like an empty toilet roll, you cut it down the middle, you can open it out and it looks like a rectangle. We know the height of this is going to be 12. What is the width of this shape? Now if you know, pause it, put it down in the comments. I'll be very impressed if you know this one straight away. The way we actually do this is it's going to be the circumference of the circle on top, because again, imagine if you cut it down the middle and open it up. The way you open it up is actually from the circumference of the circle at the top because it wrapped around there. Now we know the circumference of the circle is pi times diameter, and the diameter in this case is going to be 10, so it's just going to be 10 pi. And if we multiply those together, we get 120 pi. And then finally for the surface area, we want to do 1 plus 2 plus 3 because we're adding the surface areas together. And we're simply going to get 170 pi meters squared. It's squared because it's an area, meters because the original question was in meters. Next we have Pythagoras' theorem. I've left a big red box to put the equation into. Pythagoras' theorem you should all be confident with, and I would recommend getting confident if you're not. A squared plus b squared equals c squared. Again, I've chosen a slightly harder example where we need to do a bit of rearranging. Now, one thing you should know about Pythagoras is the long side is always going to be the c. The a and the b on the other side doesn't really matter, so I've already labelled this one a, so I might as well keep it at a, and then the other one can be b. So I'm going to rewrite the equation here. A squared plus b squared equals c squared. We, in this case, want to work out a. So a squared is actually equal to c squared minus b squared, because we take this b squared and subtract it to move it on the other side. Then all we do is simply substitute our numbers in. 13 squared take away 12 squared, 169, take away 144, leaves us with 25. So a is equal to the square root of 25, which we all know is 5. And that is Pythagoras' theorem done. Labelling a circle. I have actually made a short video on this on YouTube and TikTok, which if you don't already follow, I recommend going to do that for lots of daily uploads and little clips that will help you alongside videos like this for your GCSE revision. So starting off with this top label up here, we have a sector. So the pizza slice looking yellow area we call a sector. This line here is a chord, and the area that it encloses is called a segment. The long line that goes all the way across the circle is the diameter of the circle, and half the diameter we know as the radius. This little dot in the middle is the centre of the circle, and this little portion of the circumference is called the arc of a circle. And a lot of you should be familiar with calculating arc length and area of a sector, which is simply the circumference of the circle multiplied by the angle over 360, and also angle over 360 times by pi r squared. So remember these as well if you don't know them already. The 4 transformations can be a very tricky topic because there's a lot that you need to remember for it. Starting off with the top left one, this is going to be a reflection. So I'm going to show you what you need to write down in an exam to get all the marks for this. A reflection will normally be 2 to 3 marks depending on how hard the reflection is, but you get a mark for saying it's a reflection, and you get another mark for describing the line that it is reflected over. Now I haven't drawn actual coordinates on this one, but it's going to be roughly a reflection in the line x equals 1. Because as you can see, this would be around about the 1 on the x-axis, and it's just that line, basically. Next, we actually have a rotation. So you'd get 1 mark for saying rotation. You also need to say how much it's been rotated by. So in this case, it's 180 degrees. If it was 90 degrees, you'd have to say clockwise or anti-clockwise, but because it's 180, it doesn't actually matter. And you can see the point of rotation here, we often call the centre of rotation, would be the point -1, 1. So those 3 things would normally get you 3 marks, whereas reflection is only 2, as I said before. Next we have enlargements. So again, you'd get 1 mark for saying enlargement. You'd have to state the scale factor, and again, I'm only abbreviating it to save space, but in the actual exam, right, this is an enlargement with a scale factor of, that looks to be roughly 3. Again, you'd be able to count the squares and count the dimensions on it to see how much it's increased by. And the centre of enlargement, COE for short, of roughly -2, -2 there. And these lines are very useful to draw to help enlarge a shape from a certain point if you actually have to do the transformation yourself. So bear that in mind as well. And finally, for this last one, we have a translation. I personally find this one the easiest of them all because it's simply a translation by a vector. And the vector is the thing that kind of looks like a big tall bracket. We have two numbers that are kind of like a fraction, but without the line in between them. So what we would do here is we would pick a point on the square in this case, and we would count how many spaces has it moved to get from one to the other. So let's say that is about 7 to the right, and 1, 2, 3, 4 down. So that would be 7 minus 4. Next we have congruency. Congruency again is one of those topics that I can teach you the theory for, but I would highly recommend practicing a lot of exam questions on these because they bring up all sorts of questions in the exams. The best thing to know is the full 4 rules here. So we have side, 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 also known as SSS. We have side, angle, side, SAS. We have ASA. You can probably guess this one, angle, side, angle. And finally, RHS. If you know that one, I'm very impressed. Put it down in the comments. But for those of you that don't know, right angle, hypotenuse, and side. So a rough exam question that you could get on this one. How are these two triangles congruent? So we are told they are congruent. And I should also add, congruency means that they are identical. So make a note of that as well, because a lot of people tend to forget that one. This is quite a high level question actually, because firstly, we notice there is a right angle. So we could consider going down the route of RHS here. So they have a right angle, so we could go by the R, and that is common in both shapes. We know the H, the hypotenuse, is 5. So we would say both 5, for example. And finally the side. Now, on this one we have the side AB is 4, but on this one we have the side AC is 3. So what we could actually do here is we can use these two here, the 5 and the 3 on the second triangle, to work out AB using Pythagoras because it's a right angle triangle. And using Pythagoras, similar to how we did it before, 5 squared take away 3 squared is equal to 16. So if a squared is equal to 16, a must also be 4. So we've worked out that that is 4. So in fact they do have a common side of 4. And this triangle is congruent by RHS. That would be a rough worked example on how to do those. But again, I highly recommend lots of exam questions for those type of things. If you want to see more examples of any of this stuff I'm doing, just let me know and I can make separate videos on this for you guys. Similar shapes next. So in the blue box, I've written the scale factors, the length scale factor, the area scale factor, and the volume scale factor. So let's do a rough idea for this one. Let's say we have two triangles. We know the length of this one is 3, the length of this one is 9, and let's say the area of this one is 81 centimeters squared. And we want to find out the area of the smaller triangle. Let's call them A and B. So straight away we can work out the length scale factor because 9 divided by 3 is 3 because we need to multiply by 3 to get there. So in terms of lines and dimensions, the triangle B is 3 times the size of A. However, as we know from this box up here, the area scale factor is going to be the linear scale factor squared. So 3 squared, which is equal to 9. And if we want to go from the bigger triangle to the smaller triangle, we're going to have to divide by 9. And we're dividing by 9 because we're talking about areas here. And we have to use the area scale factor. Now we all know 81 divided by 9 is indeed 9. And the units will stay consistent for that, so 9 centimeters squared. And that is our answer. Again, this is one of probably about 1,000 different examples they could give you. So practice lots and lots and lots of questions on this stuff to make sure you can ace it when you get into those final exams in May. The sine and the cosine rule, definitely something for the higher students, so foundation, you don't have to worry about this. The sine rule, we would call it A over sine A equals B over sine B, and sometimes C over sine C. The cosine rule, A squared equals B squared plus C squared. I like to remember this similar to Pythagoras because it is so far, but then it's got a slight extension on it of 2BC cos A. So when would we use these? This is used for non-right angle triangles. So let's say we have an angle of 37 degrees here, 20 centimetre length there, an angle here of 50, and we have to work out this one. Now, we use the sine rule when we have an active pair of angles and sides opposite each other. So what we would do here is we would just use a section of the equation. We don't have to use the whole thing, just this bit here. We would say 20 over sin 37 equals x over sine 50. Rearranging this one, we would know that x is equal to this multiplied by that. So I'm just going to pop that into the calculator quickly. So just to be clear, all I've put in my calculator is 20 over sine 37 multiplied by sine 50. Keep those two separate, by the way, and your answer for x is going to be 25.46 centimetres in this case. And that will be your final answer for that one. Now for the cosine rule, it can be quite tricky to decide between the two of these rules. So the cosine rule is often used when we, again, often want to work out a side, but when we have an angle enclosed by two sides. So let's say that's 40 degrees, let's say that's 12, and that's 10. What you'll notice here is we don't have an active pair. Even though we have an angle and a side opposite each other here, we don't know the side, so we cannot use the sine rule to work this out. So we're going to let this one equal the capital A, the angle, and this one is going to equal little a, because the opposites are always capital and lowercase. This is going to be little b, and this is going to be little c. All I'm going to do is substitute this into all of this, and put it into my calculator and see what I get. Now after typing that in, I get an answer of 60.15. Now that is a squared. So we then have to square root that answer. And our final answer is 7.755 and so on. Now a lot of people get to this point and forget they have to then square root. If you've got two sides here of 12 and 10, it is fairly unlikely, unless you have a massive angle, that this side is going to be 60 centimetres long. So use that as a little trigger in your mind to remember to square root it. Okay, similar to the sine and the cosine rule, we have the area of a non-right angle triangle, so more kind of non-right angle trigonometry. So we're given the equation straight away, and we are given a rough question also here. So what I've also done is given us a harder example just to show you the extent to what these questions could be like, rather than just giving you the basic ones and then get into an exam and it's something completely different and you get completely lost. So we know the area. We're going to let this equal the A, this equal the B, and this angle must be C, because again, opposite would be the little c, but we don't need that C here. So substitute all those values in. So A is 20, then we have a half. A times B would be 6 multiplied by 10, and then that multiplied by sin, and we have to work out what the angle is, so that's going to be our x in this case. So I'm just going to simplify all this bit here. So we have 20 equals 6 times 10 is 60, and then half that will be 30, so it's going to be 30 sin x. Then if we divide by 30, sin x is going to equal 20 over 30, or 2 divided by 3. So if we want to work out x, we would have to do sin to the minus 1 of 2 over 3, pop that into our calculator, and our final answer is 41.8 degrees. Always use common sense when it comes to these questions. Does an angle of 41.8 sound about right? I would say it does, because normally a triangle is anything between 20 to 100 degrees. Anything outside of those bounds, you may have done something wrong. So always double check it just to be on the safe side. That is how we do a complicated example of finding the area of a non-right angle triangle. And last of all, we have trigonometry. So the trigonometry rules, up in the top left, I have A is adjacent, O is opposite, H is hypotenuse. This is all the sides that we're going to be talking about in a minute. And SOHCAHTOA, if you haven't heard of that before, either you haven't come across it yet in school, or if you're in year 11 and you're about to do your exams and you still haven't heard of this, I would make sure you remember it as soon as possible, because it is an absolute life hack for trigonometry. So I've also labelled what each of these means. So the S stands for sin, the O is the O, and we know that O is opposite, and the H is the hypotenuse. So just to make that clear, I've labelled all that nice and neatly on the left-hand side for you. On the right-hand side, we have labelling the triangle. Notice the angle is always opposite the side that we label the opposite. The adjacent is the one in between the right angle and the angle that you're dealing with, and the hypotenuse is always the long side going down here. So this is an example question that we have. We know the angle, and we always know that the side opposite the angle is called the opposite. The side in between the two angles we call the adjacent. So, how do we decide whether we use sin, cos, or tan? Go back to so, ca, or toa to help us decide. Now you can see in our question, we're using O and A. So which one of these contains O and A together? That would be number 3, toa. So that's the one we're going to be using. And down the bottom, we know that the toa represents tan of our angle equals the opposite over the adjacent. So tan of 52, because that's our angle, is equal to 10 over x. And rearranging this, I like to often use the triangles that you may have seen in science before. So we have our tan in the corner, the x here, and the 10 on top. So rearranging this, if we want x, rub that one out, pretend it's not there or whatever. X is going to be 10 over tan 52. And putting that into your calculator, you get an answer of 7.8. Let's say it's centimetres for this case. And that is how you do trigonometry. As I said, highly recommend remembering all of these here and be comfortable labelling the triangle as well, because it can get quite confusing. And that sums up all of the geometry and measure topic. And now our final topic, probability and statistics. If you've made it this far, well done. We do not have long left. Starting off with just some basic estimates. This is a fairly common exam question that I see quite a lot. What is the probability of rolling a 4 on a fair dice? That is just going to be a sixth. So find roughly where a sixth is going to be. I'm going to say it's about there. So we would mark that with a cross. What is the chance of someone growing to 5 meters tall? 0. For those of you that don't know, the average height for a human is anything between 1.5 and say 2 meters tall. So 5 meters is impossible. What is the probability of you passing GCSE Maths after this video? That is going to be a guaranteed 1 because you will not fail. On a serious note, a normal question like this in an exam would be something like, what is the probability that the sun will set tonight, or the probability that the sun will rise tomorrow? It's always going to happen, so you just put that at 1 or 100%. Next, we have probability trees. Again, something I highly recommend you get comfortable with. They have lots of different scenarios they could ask you on for this. So reading the question, we have 5 blue counters and 3 red counters in a bag. I take one and don't replace it. That is a key part here. So first of all, we have 8 counters in total, so our probability is going to be out of 8, for the first pick at least. So the probability of getting a blue one is going to be 5 out of 8, because there's 5 of them, and the red is going to be 3 out of 8. Now for my second pick, because I don't replace it, the total is now going to be 7, and because originally there was 5, assuming I've already taken a blue one, there is now going to be 4. And the red is just going to fill in the gap, so 3 out of 7, because there's still 3 left. We haven't taken a red one according to that pathway. Now going on to the bottom branches, if we take a red on the first one, the second chance of that is going to be 2 out of 7, because we've taken one red out, leaving the blue to stay at 5 over 7. Now the question is asking us, what's the probability of getting 2 blue counters? The way I like to look at these is I take a highlighter and I highlight the pathway that is going to lead me to my answer. As you can see, that is going to be across the top there. When we want to work out the probability of a branch, we multiply. The two things are dependent of each other. So it's the probability of getting a blue and another blue. So we do 5 over 8 multiplied by 4 over 7. 5 times 4 is 20, 7 by 8 is 56. And that is going to be our final probability. Probability tables, another variant of the probability trees which you could see. Now, before anything, if you see this, just know all those probabilities have to add up to 1. So adding those 3 up, we get 0.6, so yellow must be 0.4. Now if you have a look at the rest of the question, fill in the table, and if the spinner is spun 300 times, how many times should it land on yellow? We know that the probability of getting yellow is 0.4. Or, if we were to convert that, that would be 40%. So, 40% of the time, it lands on yellow. So if we can work out 40% of 300, there is our answer. The easiest way to do these, as we've seen before, 100% equals 300, so 10% equals 30, and then multiplying that by 4 is going to be 120, and that is going to be our answer. Sampling. Very common in exams, and also something that happens a lot in real life when it comes to experiments and stuff like that. 30 people from a 600-person school are asked how did they get to school. Here are the results. From this, what estimate of the whole school walk to school? Now we can assume that the sample is representative. As you can see in our sample, 10 out of 30 people walk to school. But the school actually has 600 people in it. So what have we done to multiply between 30 and 600? We've multiplied that by 20, so we can scale it up by a factor of 20. So it is safe to assume from our sample that 200 people walk to school. What could be improved about this questionnaire? A very common thing when it comes to sampling is more people. That is as simple as it is. Because if you think about it, if you were to ask 2 people and they both said, oh, we both drove to school this morning, then if you scaled that up, everyone would have driven to school. But if you instead ask 100 people, you're going to get a much broader range of results and it's going to represent a bigger population. So always think about more people. Displaying data. It's very important that you are able to recognize and understand how to plot different types of data. I've just drawn a few diagrams of a couple different types. I'm sure there is many that I've missed. But the first one here, we have bar charts. Notice how the width of the bars are all nice and uniform. The next one we have is a pie chart. After this, a bit more obscure, but a pictogram. They're often used, especially at the foundation level or the early questions in a higher paper. Next, we have a scatter graph with a line of best fit. This one is a bit more obscure as well. This is called a cumulative frequency curve, something we will look into a bit more in a minute. And finally, a histogram. The big giveaway here is that all the bars have different widths based on the classes that they come from. You need to know a little bit more about scatter graphs compared to the other ones. Here I have labelled the positive, negative and no correlation that you need to know about. Another thing to point out is on a scatter graph, a line of best fit is very important. One thing about the line of best fit is it does not have to go through the origin. There are so many people I see that miss out on marks because they always think it does. Just draw the line where it looks best. Cumulative frequency and box plots. So there's a lot going on this page and the exam questions are often quite well rewarded. So you'd start off with a table up here like this where you have grouped frequency tables. The cumulative frequency is the frequency as we go down. So we start off at 6 and then we take our 6 and we add 10 to it because that's the next one, so 16. Add 8 to that, we get 24, and then add 3, we get 27. That is how we would do our cumulative frequency. We would then display this on the cumulative frequency curve like this, with the cumulative frequency going up the side and the ages at the bottom. From this graph, as you can see, these dotted lines I've drawn on it can give us values such as the lowest, lower quartile, median, upper quartile and highest value. So again, I've made a rough estimate of what those values will be here, and we can then be asked to plot them on a box plot. So what we would do is we'd find our, first of all, the lowest value at 5, and we would draw a line just like that. The lower quartile at 15 is going to be just here. The median at 35, a little bit further up, but here. Upper quartile 60, and finally the highest value at about 72. Let's just say that's around about there. And then you link up these ones. For those of you that have seen a box plot before, this will be very common knowledge to you. And our final result should look something like that. Just a side note, it doesn't have to be symmetrical or anything like that. So just go with your gut and trust yourself that you know what you're doing here. And now our final topic of histograms. You get a very similar setup to the cumulative frequency for these, where you have a grouped frequency table. Sometimes these columns aren't included, so it's up to you to draw them yourself. So starting off, you'll notice this class width column. For those of you that haven't seen that, we then have to look back to our groups at the front, and we have to think about what is the width of each of those classes. So 0 to 15 is obviously just going to be 15. 15 to 40 is going to be 25. 40 to 60 is 20, and finally 60 to 80 is also 20. Now using this equation, frequency density is frequency divided by class width. So by drawing it in this order, it makes it very easy to just do the calculation. So 60 divided by 15 is 4. 50 divided by 25 is 2. 10 divided by 20 is 0.5 or a half. And 30 divided by 20 is 1.5. What we then have to do is plot this data onto our histogram. So what you'll notice about this one is the bars aren't necessarily the same width. So we would take our 0 to 15 column and draw that up to the 4. So it would look a bit like that. Our next column is between 15 and 40, and that goes up to 2. And you continue to do this until you have a full histogram. So I've just added in those final 2 bars, and this is what your final thing should look like. And that sums up all of GCSE Maths in one video.
If you made it this far in the video, I hope you found it useful. If there's any parts of the video that you think I've missed or you want me to go into a bit more detail, let me know in the comments and I will try and get a video out for you on that. I also want to say thank you so much for watching and I wish you the best of luck with your exams.